Hey guys, we're going to do notes today over radian and degree measure. So we're going to start off making sure we understand about angles. So first of all, this point right here, if you'll recall, is the vertex of the angle. When we're talking about an angle, we're going to want to just make sure we know some vocabulary. So this side right here, we can call it the initial side. And when we rotate this, it's going to rotate to this other side, which is called the terminal side. So this year, as we're starting to talk about angles, our angles are going to look more like the one on the right. So when we do this one, this side right here, this would be our initial side. And what you're doing is you're kind of looking at it like on an X and a Y axis, so like on a coordinate grid. So where the x-axis is positive, that's where our initial side will always start. Your vertex will always be at the origin. That's their vertex. And then we're going to rotate that initial side to get to the terminal side. So if I rotate it this way, that would be our terminal side. Now I went counterclockwise with that rotation. I could have gone clockwise, which would have just made it where the angle would have gone in this direction. And we're going to talk about different directions and what that means about our angle next. So let me move this up. So when we want to make a positive angle, we're going to do that rotation counterclockwise. Remember, counterclockwise goes in this direction. So again, we're going to start right here on the positive x-axis. And when you go in the counterclockwise direction, this would represent a positive angle. When you start with the positive x-axis and you go in the clockwise direction, you're going to end up with a negative angle. So that would be a negative angle. So let's just look at an example. Let's say we have a coordinate grid like this, and we want to do an angle where we start here at the positive x-axis, and we'll have this angle right here with this terminal side. So going this way, this would be like a positive 120 degrees, for example. If I had gone in the other direction, if I had gone in the negative direction, then that would be a negative 240 degrees. Remember, a full circle has 360 degrees. So starting right here, this would be where we start. That's a 0, and so we would just went around this way. Counterclockwise made it negative 240. Going clockwise would have made it a positive 120. Either way, though, they end up with this same terminal side. So when you have the same terminal side for two different angles, that's called coterminal. So let's just look at some different examples of those. Let's say I have an angle right here. Let's just make this about a 60-degree angle, say. So from here to here, that makes that a positive 60 degrees. If I had gone in the negative direction, so if I'd gone clockwise, that same terminal side would give me a negative 300 degrees. Now, that's just two angles that would be coterminal. There are an infinite number of coterminal angles with that same terminal side right there. So what we also could have done, choose another color, let's do green. I didn't have to stop at 360. I could have done one full circle, that's 360, plus another 60, which would have made that 420 degrees. So 420 degrees is also coterminal with negative 360. I could have gone even more times around. So negative 300, 60, and 420 degrees. Those are all coterminal angles. All right, let's do another example of coterminal. Let's say my angle is just right here. We'll make it right here. So in the positive direction, that would be 90 degrees. In the negative direction, going this way, that would be negative 270 degrees. Let's say I didn't want to stop at just one circle, or I wanted to go past 360, so go around once, and then I'm going to keep going. So I've gone around it 2 times. So basically what we're doing is we've gone 90 degrees, but we added 360 to it, and then we added 360 again to it because I did 2 full circles. So that would be, that's a 36, it's a 810 degrees, sorry. So negative 270 degrees, 90 degrees, and 810 degrees are all coterminal angles. They all have the same terminal side. Okay, next we're going to talk about different ways to measure an angle. So normally I think we're more familiar with the units for an angle measured being in degrees, but we have another option where the angle measure could be in radians. So when that's the case, this below is kind of a definition of a radian. Basically, whenever your radius and your arc length are the same, then that represents 1 radian. So that's what it's saying right here. When the arc length and the radius are the same, then that equals 1 radian. So if you'll notice on this picture on the right, here we have the radius and we have this arc length that's the same, so that's 1 radian. Add that same arc length to that represents 2 radians. Add another one, that's 3 radians. And if you'll notice right here, we've gone a little past 3 radians to get to this point right here. So that's actually half of a circle, which would end up being, that's about 3.14 or pi radians. Add another arc length right there, that would be 4 radians. Add another arc length, that'd be 5 radians. Add another one, that's 6 radians. And so add a little bit more past that, that would be 6.28 or about 2 pi radians. So 2 pi is full circle. So what we're wanting you to see is that, just kind of understand the difference between what a radian measure and a degree measure would look like. So let's move this up. So what I want you to think about is on an x and a y axis, if I created a circle on that x and y axis, so starting right here, this would be where 0 degrees is. A half a turn would make that, or I'm sorry, a quarter turn would make that 90 degrees. All the way halfway around would make that 180 degrees. And then another 90 degrees would make that 270, full of 4. To get a full circle, that's 360 degrees. Now we just talked about how halfway around the circle, whenever you're talking about radians, would have been pi. So from 0 to pi, halfway would have been pi over 2. So that means 90 is the same thing as pi over 2. 180 is the same thing as pi. And so I'm basically, each time I go to one of these quadrants, this was a pi over 2, this is another pi over 2. This is another pi over 2 right here, making this 3 pi over 2. And then a full circle to get to this one right here makes this 4 pi over 2, which is the same thing as 2 pi. So I'm wanting you to see that pi equals 180 degrees and 2 pi equals 360 degrees, and kind of how to divide up that circle into those degrees. Again, going in the counterclockwise direction makes those positive angles. All right, let's divide that up a little more. I'm going to erase that real quick and kind of redo it. So starting again, right here is 0. We talked about how this was 90 degrees or pi over 2. So halfway between 0 and 90 would be pi over 4. So then I'm going to be adding pi over 4 each time. So here's 1 pi over 4. Right here would be 2 pi over 4, which is the same thing as pi over 2. Then I'm going to add another pi over 4, which makes this 3 pi over 4. Add another pi over 4 right here, which makes that 4 pi over 4, or just pi. Add another pi over 4, making that 5 pi over 4. This would be 6 pi over 4, which is the same thing as 3 pi over 2. This would be 7 pi over 4. And then right here would be 8 pi over 4, which is the same thing as 2 pi. So now we've counted in increments of pi over 2. We've counted in increments of pi over 4. So I want you to also think about how, this was at 90 degrees right here. Halfway between 0 and 90 would be 45. So this pi over 4 is the same thing as 45 degrees. So we weren't just counting in pi over 4s, we were counting in 45 degree increments. So it went from 0 to 45 to 90 to right here would be 135 degrees. This was 180. And then this would be 215. This would be 270. And then right here would be 315. I totally did that one wrong over here. This was 225. I'm sorry about that. And then 270, and then 315. And then to the full circle was 360 degrees. Okay, so over here on the right, we have a picture already drawn for you where they're counting in increments of 30. So we've gone from 0 to this 30 to 60 to 90 to 120. We're just adding 30 degrees every time. Well, you know, if we know that pi is the same thing as 180 degrees, then pi over 6, that's like saying 180 divided by 6. Well, that's 30 degrees. So now we're going to be counting in increments of pi over 6. So right here was 0, and then we've got pi over 6, 2 pi over 6, which is the same thing as pi over 3, 3 pi over 6, which is the same thing as pi over 2, 4 pi over 6, which is the same thing as 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. And where those can be simplified, they simplified them. Okay, so that's just different ways to break up a full circle. You know, you start right here on the positive x-axis and you rotate it counterclockwise to get those positive angles. And it's kind of showing you where they're located. So the other thing I'm wanting you to see, let me erase all this, is the fact that, you know, we were talking about this is our y-axis and this is our x-axis. We're basically dividing the circle up into quadrants. We've got that this is our first quadrant, this is our second quadrant, our third quadrant, and this is our fourth quadrant. So we're going to be thinking about those angles and where they're located based on what quadrant they're in. Okay, so this first example, they're wanting us to sketch and find any coterminal angles with 13 pi over 6. So basically the best way to get coterminal angles is you're going to go full circle from where this angle is by adding either 360 degrees or adding or subtracting 2 pi. So to get coterminal angles, you'll always add or subtract either 360 degrees if the angle was given to you in degrees, or you're going to add or subtract 2 pi, which is the same thing as 360 in radians. So you're going to add or subtract 2 pi to get a coterminal angle. So 13 pi over 6. So, you know, right here is where 0 is. Right here we talked about was pi, which, you know, we want to have a denominator of 6 because that's what this denominator is. So this is the same thing as 6 pi over 6. So halfway right here between 0 and 6 pi over 6 would be 3 pi over 6. So we're now counting in increments of 3 pi over 6. So this would be 9 pi over 6. And then a full circle would be 12 pi over 6. So you're going to go another pi over 6 past 12 over pi over 6 to get to 13 pi over 6 right here. So we went full circle to get to 12 pi over 6 and then another pi over 6 to get right here at 13 pi over 6. So this would be our coterminal, well, this would be a coterminal angle with actually pi over 6. And the way we would see that is you can take that 13 pi over 6 and you're going to subtract 2 pi from it. So that would be 13 pi over 6. You're going to subtract 2 pi, but you need a common denominator to do that. So it'll be 12 pi over 6. And then when you subtract those two, you get pi over 6. So pi over 6 is a coterminal angle with 13 pi over 6. And you could do it again and get another coterminal angle. So subtract 12 pi over 6 again, which is 2 pi, and you get a negative 11 pi over 6. So this is also coterminal. And you can keep doing that over and over and over again. So again, how we could find a negative coterminal angle, we just did that right here by subtracting 2 pi again. Okay, so now they want us to find a positive coterminal angle to 3 pi over 4. So let's first locate where 3 pi over 4 is. So this is 0, this is pi. With the denominator of 4, it's the same thing as 4 pi over 4. Halfway between 0 and 4 pi over 4 would be 2 pi over 4. Oops. So 3 pi over 4 would be located right here between 4 pi over 4 and 2 pi over 4. So this is 3 pi over 4. So we're going to find a coterminal angle with that, which means that it has the same terminal side right here. And they want us to subtract 2 pi to do that. So 3 pi over 4 minus 2 pi would be 3 pi over 4. I'm going to subtract 2 pi, but I need it to have a denominator of 4. So that would be 8 pi over 4, which when you subtract those, you get negative 5 pi over 4. So what that means is whenever I do, starting here at this initial side, if I go clockwise, that would be this angle right here, and negative 5 pi over 4. All right, then they want us to find another coterminal angle, and this time the angle that we're starting with is a negative 2 pi over 3. So this is 0, this is pi. Going in the clockwise direction, that gives us a negative pi. So we need to have a denominator of 3, so this is negative 3 pi over 3. Halfway would be a negative 1.5 pi over 3. So that means a negative 2 pi over 3 would be located in this quadrant. So they want us to add 2 pi to negative 2 pi over 3 to get the coterminal angle. So negative 2 pi over 3 plus 2 pi, that'll be negative 2 pi over 3 plus 6 pi over 3, which is 4 pi over 3. So a positive coterminal angle with negative 2 pi over 3 means that that would be 4 pi over 3. So 4 pi over 3 and negative 2 pi over 3, those are coterminal angles. All right. Now we're going to convert between degrees and radians. And like I said a while ago, pi, was the same thing. That's a terrible looking pi, sorry. All right, pi is the same thing as 180 degrees. 2 pi is the same thing as 360 degrees. If I did pi over 3, that's the same thing as 60 degrees, because I'm basically saying 180 divided by 3. If I did pi over 4, that's 45 degrees. Pi over 6 is the same thing as 30 degrees. And then I forgot about pi over 2 is 90 degrees. Okay, so those are easy ones to do. We're going to have to do some that are not quite so simple. So if I want to convert 135 degrees to radians, these are the directions. You're going to multiply it by pi radians over 180 degrees, because it's almost like you're doing a conversion from feet to inches, where you're going to multiply it by 12 inches over 1 foot, because those are the same. They are the same measure, but just different units there. Well, pi radians is the same thing as 180 degrees. So we're going to take 135 degrees, we're going to multiply it by pi radians over 180 degrees. That way your degree symbols will cancel out. When you multiply that straight across, you get 135 pi over 180. And then you should try to simplify where you can. 45 goes into 135 3 times, and 45 goes into 180 4 times. So that gives me 3 pi over 4. 540 degrees, I'm going to convert it to radians. So 540 degrees times pi radians over 180 degrees. That way my degrees cancel, and I end up with 540 pi over 180. Now 180 goes into 543 times, so that would be 3 pi. Okay, next we've got negative 270, so negative 270 degrees times pi over 180. So multiply straight across, we get negative 270 pi over 180. By the way, that 180 had degrees, and those degrees ended up canceling out. All right, so when I simplify this, I know that 90 goes into 180 twice, and it goes into 273 times, so this is a negative 3 pi over 2. Okay, now we're going to convert from radians to degrees. And remember that 180 degrees is the same thing as pi radians. So this first example, we have a negative pi over 2 radians, you're going to multiply it by 180 degrees over pi radians. That way your radians will cancel out. Multiply straight across and you get negative 180 pi over 2 pi. So simplifying that, you know that pi's will cancel there. 2 goes in 180 90 times. So that's the same thing as negative 90 degrees. Now that's the long way to do it. A lot of times I'll just remember that pi is the same thing as 180. So I'll do negative 180 divided by 2 to get that negative 90 degrees. That's easy to do when they have pi there in the actual problem. On B though, they don't have that. So you have to actually do the conversion. You'll do 2 radians times 180 degrees over pi radians. That way the radians cancel out. Multiply straight across. Remember, 2 radians is the same thing as 2 over 1. So that gives me 360 degrees over pi. And that would be my answer. Here I'm going to be lazy. I'm just going to replace pi with 180. So that's 9 times 180 divided by 2, which would be 810 degrees. Okay, next we need to remind ourselves of what complementary and supplementary are. 2 positive angles are complementary when their sum is 90, and 2 positive angles are supplementary when their angles or their sum is 180. So they want us to find one of each. So to do a complementary, I would do 90 minus 72, and so that would be 18. So 18 degrees is complementary to 72. Okay, to do supplementary, I'm going to do 180 minus 72 degrees, which is 108. So those are my complementary and supplementary angles. 148, I'm going to do for complementary, I'm going to do 90 minus 148, which is a negative 52. That's not positive. So we would just say there's no complementary angle. Supplementary would be 180 minus 148. So that's 32 degrees would be supplementary. All right, 2 pi over 5. So complementary, remember they have to add up to be 90, which is the same thing as pi over 2. So we're going to do pi over 2 minus 2 pi over 5 to get the complementary angle. Well, we need a common denominator, so pi over 2 is the same thing as 5 pi over 10. And then 2 pi over 5 is the same thing as 4 pi over 10. So when we work this out, we'll get that the complementary angle is pi over 10. Supplementary would mean that they have to add up to pi, or I'm sorry, yeah, pi, because that's 180 degrees. Okay, so then we'll do pi minus 2 pi over 5. We need a common denominator, so we need to have a denominator of 5, so that'll be 5 pi over 5 minus 2 pi over 5, which is 3 pi over 5. All right, on this next one, we're going to do, to get my complementary, I'll do pi over 2 minus 4 pi over 5. So we need a common denominator. That would be 5 pi over 10 minus 4 pi over 10, which would be pi over 10. Okay, next for supplementary, we're going to do pi minus 4 pi over 5. So that's the same thing as 5 pi over 5 minus 4 pi over 5, which would be pi over 5. You know what? I think I messed something up. Hold on. Well, I did not mean to erase all of that. Sorry. So to do my complementary here, I would be doing pi over 2 minus 4 pi over 5. I don't know what I messed up because I erased it, but I know I did something wrong. I think I figured out. My common denominator has to be 10, so that'll be 10 here and 5 pi over on top. So 5 pi over 10 is pi over 2. Here I need my denominator to be 10, so this is 8 pi over 10. When you subtract those, you get negative 3 pi over 10. This is negative, so that means that there's no complementary angles. Supplementary would have been pi minus 4 pi over 5. So that's 5 pi over 5 minus 4 pi over 5, which is 1 pi over 5. Okay, now that's finally done. Sorry. Okay, let's move on to linear and angular speed. All right, linear and angular speed. We need to first focus on arc length. So in geometry, we talked about when you have a circle, the distance around that circle is the circumference, which we do 2 pi r to get the circumference of a circle. When we do arc length, we're only talking about a fraction of the circle's circumference. So to get the fraction of that circle, we figure out what this angle is right here, which we usually just call theta if we don't know the actual angle measure. So to figure out the fraction of that circle, we'll do theta divided by 360 times the circumference formula, 2 pi r. Now we're usually going to be using radians, so I'm going to replace that 360 with 2 pi, because 2 pi is the same thing as 360. And then multiply that by the circumference, so 2 pi r. So when you do this, hopefully you can see that those 2 pi's will cancel, and it's just theta times r. All right, so that looks an awful lot like this formula right here that we have. And that's basically how we get it. So as long as theta is in radians, we can use this formula. If theta is not in radians, then you can use this formula. All right, let's do an example 5. A circle has a radius of 4. Find the length of the arc intercepted by the angle that's 240 degrees. So remember, right about here is 180. So 240 will be about right here. So that is 240 degrees. Okay, so we can either, I'm going to use the new formula, S equals R times theta, which means our radius is 4 and our theta is 240. So I need 240 degrees to be converted to radians, so we'll do 240 times pi over 180. And then if I multiply straight across, I get 240 pi over 180, which simplifies because 60 goes into both of those, so 4 pi over 3. All right, using my formula, R times theta, R is 4, and theta is going to be 4 pi over 3 in radians. So that's equal to 16 pi over 3. Okay. Okay, another example. The circle has a radius of 27. The arc length, the central angle is 160 degrees. So this is 160 degrees. So we can find our arc length by doing R times theta. Again, my radius is 27. My angle is 160 degrees. Because it's in degrees, we have to convert it to radians. So I'll multiply that by pi radians over 180 degrees. So I get 160 pi over 180, which ends up being 8 pi over 9 in radians. So I'm going to multiply the radius, which is 27, times theta, which is 8 pi over 9. The 9's cancel, so it's 9 goes into 27 actually 3 times. So that ends up being 24 pi is my answer. All right, now we're going to use that to figure out linear and angular speed. So linear speed happens to be the arc length divided by time. And then angular speed is the angle divided by time. And also just think about the way we get the arc length is we do R times theta divided by time. Well, if you'll notice right here, this is theta divided by time, which is the same as the angular speed. So we could also think of linear speed as R times angular speed. Just another option depending on how you were given the information. Okay. Okay, let's do an example. We have a second hand of a clock, so think of a clock. So you've got your minute hand and your hour hand, and then there's the second hand as it travels around the clock. So that minute hand or second hand is a radius for the circle that it creates. So the radius is 10.2 centimeters. Find the linear speed at the tip of this second hand. So linear speed equals r times theta divided by time, not 6, but time. Okay. So we were told our radius is 10.2. I already wrote that. And then our theta, as we go one full circle, our theta would be 2 pi. The time it takes me to do that, it would be 60 seconds in this case. Okay, so plugging that in, we get 10.2 times theta, which is 2 pi, divided by 60 seconds. So 10.2 times 2 would be 20.4 pi over 60. And that would be our answer. All right, then we have a wind machine used to generate electricity has blades that are 10 feet in length, so the radius is 10. The propeller is rotating 4 revolutions per second. So that means it does 4 full circles, so 4 times 2 pi, which would be 8 pi. And the time it took it to do that would be, it did 4 revolutions per second, that would be 1 second. Okay, so we can use our formula. The radius is 10, the angle is 8 pi, and it takes me 1 second to do that. So that's 80 pi, and then my units for that would be in feet per second. Okay. All right, another example is a Ferris wheel with a radius of 25. It's rotating 3 revolutions per minute. So our theta will be 3 full circles, so 3 times 2 pi, which would be 6 pi. Our revolutions would be in feet per minute. So our time it takes me to go those 3 revolutions would be 1 minute. And this was in feet, so that matches what they're needing. So a linear speed is r times theta divided by time. That's 25 feet. Let's see. It takes us 1 minute to do that. 3 full circles, which is 6 pi. So if I multiply that out, I get 150 pi feet per minute. Okay. Next example, we have a Ferris wheel with a radius of 50 feet. The right angle is 1.5 times 2 pi, so 1.5 full circles, which gives you 3 pi. And the time it takes you to do that is 1 minute. And they want radians per minute, so we've got the units right on the time. So when we do angular speed is, oops, I said that wrong, sorry. So to get angular speed, we're going to do theta divided by time. So theta is 3 pi, time is 1 minute. So we end up with 3 pi radians. Okay, next we're going to find the linear speed. So, and this time they want it in feet per second, so we've got to pay attention to that. So linear speed would be r times theta divided by time. My radius is 50. My theta was 3 pi, and the time it took me to do that was in 1 second. Or I'm sorry, I said that wrong. It took you 1 minute to do that. So based off of that right there. So we need to convert this, because they're wanting in feet per second, convert that 1 minute to 60 seconds. And then we can finish solving it by multiplying. So that ends up being 150 pi on top divided by 60. And then we just need to simplify that. So 30 will go into this 5 times, and 30 will go into this 2 times, so it'll be 5 pi over 2. All right, last example. We have a 15-inch diameter, which means the radius is 7.5. So radius is 7.5 inches. Theta, it took me 9.3 revolutions to go around a full circle. So that's 18.6. And the time it took me to do that was in 1 second. So I've got, I'm trying to find angular speed. So it'd be the angle divided by time. My angle is 18.6. I forgot to put the pi on that, sorry. 18.6 pi over time. It took you 1 second to do that. So it's just 18.6 pi. Radians per second. Now to find the linear speed. Remember a while ago we said linear speed was r times theta divided by time, but that's your angular speed. So you're just going to do r times the angular speed, which r is 7.5. And then my angular speed was this 18.6 pi. And then you're just going to multiply that out. Okay, I accidentally erased that, so here it is all worked out again. So when you multiply that out, you get 438.252. And my units for this would be inches per second. And that would be your answer. All right, thanks guys. Bye-bye.